Alrighty guys, we're going to do our last page here, page 82, about our absolute value functions and equations and how they all kind of work together. It's so cute. Alrighty, so when we were talking last week about solving absolute value equations, we wanted to get our bars all alone. Now these bars are not alone, there's a half in front of it, so to get rid of a fraction, we multiply by the reciprocal, so 2 over 1, which is really just 2. And so then we'll have absolute value of x minus 1 equals 8. Once your bars are alone, we make our two equations. One that is exactly the same, so x minus 1 equals 8, and the other one where I simply change the outside number, so x minus 1 equals negative 8. And then I just solve each one. And so I'd add the 1, and x is 9. I add the 1, and x is negative 7. Now, a super interesting thing that we can do is we can also think about this graphically. So if I take what I had originally and one side of the equal sign, so the half absolute value x minus 1 becomes one equation, and then the other side of the equal sign becomes my other equation, then I can graph each one, and like we were doing in our last chapter, find where they touch each other, and that's your solution. So if I put some grid lines on there, I'm going to graph this first one in red, and then I'll graph the second one in blue. Okay, so this first one is an absolute value graph. I always like to find my vertex first, which will be at 1, 0, because inside number is always opposite, and there's no outside number, so 1, 0. Then the number being multiplied is my slope. So from here, I'm going to go up 1 over 2, up 1 over 2. And I get the v going in this direction, but now I need to get the v going in the other direction. So up 1 backwards, 2, 2, 1, 2, 2. Okay, so we have our v graph. Then the bottom one is kind of like a y equals mx plus b, but really it's just a number. And when it's just a number like that, it's a horizontal line through that number. So I go to 4, 1, 2, 3, 4, and I just look for where the two lines touch each other. Oh my gosh, and it almost doesn't. So right here, we're touching at the point 1, 2, 3, 4, 5, 6, 7, negative 7, comma 4, which negative 7 was one of my answers. And then this other one, it looks like it would cross like right at the next square, which was 1, 2, 3, 4, 5, 6, 7, 8, 9, comma 4. Oh, I just wish I would have made my graph a little bigger, which again, I can see 9 was my other answer. So there you go. What do you notice? They're the same. Like, we don't have to answer that. So let's try one more that's a little different. Okay, so solve over here, or I can graph over here. I'm gonna graph first this time. Let's see. So with the graphing one here, again, I'll do this top one here. Let me get some grid lines going again. When I need to be up at 12. So I'm gonna do my grid lines kind of down here. Like real low. Hopefully I made it low enough. I don't know. I might have to count by 2s. All right, so this top one, I'm going to graph in red. It is an absolute value, so it's going to look like a V graph. Your vertex is at 3, 4. So 1, 2, 3, 1, 2, 3, 4. Your slope is 1 because there's no number in front, so I'll do up 1 over 1 on either side. And then I need to get the other side of my V graph, so we'll go this way. Now, your other line, again, is just a single number, and it's 12. So I need to go to 12 on the y-axis and just draw a horizontal line, and I'm really hoping that I can count by ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yes. Oh my God, that's close. This one, though, is not equal to. It's greater than or equal to. So that I have to remember, like, do I do a dash line? or a solid line. And because there's a line under, it's a solid line. Then I need to shade, and it's kind of not crossing, but I like to put it eventually. I need to shade, and this is saying that it's greater. So I need to be greater than that line, so above it. So that would be all this stuff up in here, like within the absolute value bars, but also above that line. And so now if we try this one and solve it algebraically, we should be able to see that I get lots of answers and they should make sense. So let's try it. So I always need to get my bars alone. So I'll subtract that 4. And we'll have absolute value of x minus 3 is greater than or equal to 8. Now that my bars are alone, I can make my 2 equations. And I should think about, because this is greater, it's or. And so we'll have x minus 3 is greater than or equal to 8. And then x minus 3 is less than or equal. Got to switch the sign. When you switch the sign, negative 8. And so then I'll solve each one. I'll add the 3 here. And x is greater than or equal to 11. Which, if I think about that, if I go to x equals 11 on here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, like that would be up here, and greater is above, so that's good. And then also when I solve over here, we add 3. We get x is less than or equal to negative 5. And so if I go to negative 5, 1, 2, 3, 4, 5 on the x, and go up here, less than continues out in that direction. And so it all makes sense, and hopefully that's fine. And yeah, there you go. Good luck.